Fernando, please introduce yourself and tell us about how a farmer in Argentina, using preparation for inoculation and what you doing in your institute about your research and experience. Tell us, please.
Yes, my name is Fernando Salvagiotti. I work here with INTA, is the National Research of Agricultural Research in Argentina. My specialization is in plant nutrition, maize, soybean, and I have a lot of publication with nitrogen fixation and the role of nitrogen in the soybean crop. Here in Argentina, we are the third producer in the world, and we have a good success with producing soybeans, especially based on a nitrogen from soybeans came always from soil and the inoculants, and we have a good about 60% of the requirements of the soybean are covered by the biological nitrogen fixation. So we always ensure that we have a good inoculation, even in fields with high soybean cultivation, because we ensure that the nutrition of nitrogen is not lacked in this field. So this is the base of our production: the inoculation, a good fertilization with other nutrients that promote the growth of the crop, phosphorus, for example, or sulfur. That's our main problems in our field. So I can begin with my presentation, or?
Yes, please.
I thought it was just a question.
Tell us more about your experience, please.
Okay. In these 15 minutes, I will try to remark the importance of inoculation for soybean production, and I will share some of our experience in Argentina. I just introduced myself. I work with INTA, always with CONICET. That is a research institute in Argentina. Well, I always begin my presentation with this type of slide, introducing about what we need to make crop production, what we need to produce some kind of field. So a crop just has to collect radiation, depends on how much dioxide, carbon in the air can capture. But the high production we have will be when we can catch the water that make us increase the CO2 capture. But nutrients are crucial for this. So I will, in this framework, I will talk about important nutrient is nitrogen. How soybean has to deal with this nitrogen capture. So nitrogen is important for the photosynthesis process. The nitrogen is accumulated as Rubisco. Rubisco is the enzyme that make the photosynthesis process, and that's why all the production is always linearly related with nitrogen uptake in crops. But also the seed nitrogen is important to have a protein content. For example, the protein reserves that we know that is important for the crops, for the commercialization of the crop. So we have two main important issues to cover with the nitrogen: the photosynthesis, the production, and always the seed protein content. So the first question is: we have soybean. How much nitrogen does the soybean crop need? So we make a great review here with a lot of fields, and we see that as with more nitrogen we have, the more field we have here. And on average, we have seen that we need approximately 80 kilograms of nitrogen to produce 1 ton of seed field. All right, this is what we need. That's for you to have in mind. Maize requirement to produce 1 ton of maize is 20. Okay, it's 4 times the requirement of a maize crop. So, and this nitrogen, where it comes from? If we have here a crop, a soybean crop, and this is a simplified nitrogen cycle. All these red boxes represent the losses that from systems, fertilization, nitrification, erosion, etc. But if we simplify and we just take how much nitrogen the crop must have taken, 80 kilograms, and harvest, this nitrogen comes from the soil, from the nitrates, that the way that the crops take up nitrogen from the soil, and from the biological nitrogen fixation. I think that the colleagues previous to me talk about the important relationship between the bacteria, the soybean bacteria, specifically for soybean, to capture the nitrogen. This is a biological process that only this type of bacteria can do in a symbiotic way. So, if we see how important is the biological nitrogen process, we can plot here seed yield and nitrogen fixation. So you can see here also that the more nitrogen fixation we have, the more seed yield we can get. But if you look, you can see here the green dot here is when we have very low supply from the nitrogen fixation. So here we have a very low supply for only 30 kilograms of nitrogen per ton. But as long as we improve the biological process by inoculation, making the crop control for the crop better, we can this supply, and we can have here that if the contribution from biological natural fixation is between 40 to 70%, we can have 50 kilograms of nitrogen fixed per ton. And also, if we increase more than this number, we can increase. So biological nitrogen fixation and seed yield are closely related, and it's important for to improve this part of the nitrogen supply. Here we have a picture, and we have here is a non-nodulated soybean, and it's close to a nodulated soybean. That's the soil. And we can see here that as we increase the length of the cycles, we go from the B6 period to of the maturity, represents the nitrogen requirement. And the nodulated soil can support this requirement. So we can, at this point, we can make a little balance. For example, if we have a soybean that yields 4 tons, and we said before that we need 80 kilograms per ton, this is the requirement, 320 kilograms of nitrogen. If our soil can give us 120, 121 kilograms, that is typical from an Argentine soil, and biological nitrogen fixation can give us 55%, we see that total requirement of nitrogen in the soil, there is a noise there. Thank you. The total requirements of the soybean can be met by soil and the nitrogen fixator. When we have a balance in maize crop, we have less nitrogen demand, we have a higher yield, we have these 200 kilograms of nitrogen of requirement. Look at it, it's very different from the soybean requirements. The soil is the same, but we don't have the biological nitrogen process. So in this case, we need to add the nitrogen with the fertilizer. So in soybean, we don't need fertilizer. In maize, obviously, yes. We don't have the biological nitrogen fixation process. So what is important to have a very good nodulation system developed in the soybean in the upper 20 centimeters of soil is when we need the better nodules, and this is obtained when we have a good inoculation, for example. We have here some pictures showing the same, and here is a more internal showing the nodule, how it's working. Here is the symbiosome that's working, and this is what is working, fixing the nitrogen from the air. So it's important to have a good mass of nodules in the upper 10 centimeters soil. And we can check this in the field, because when these nodules are active, they are the red color. For example, when we are fertilizing soybeans, we have these non-active nodules because they are not working. So the sign that we can get in the field to have a very good inoculation is to have not only the nodules, but the nodules working, and we can check these by taking the roots from the field and checking the color of the nodules. So here is the impact in seed yield. This is an experiment in Argentina. We have fields that have more than 40 years of soybean or continuous soybean or rotated, but we have a very, so this is all more or less studies showing us. So look at this, is a control in a field with no soybean history. This is the inoculated, and you say that the inoculation can get the same yield as applying 400 kilograms of fertilizer nitrogen. So here we have the clue. We are feeding the nitrogen, the soybean with the nitrogen they need just for inoculating, not adding fertilizer nitrogen. We are just like replacing. This is a 20% increase, for example. But when we go to fields with large history of soybeans and we plot the known seed yield without inoculation, sorry for the language, this is seed yield with inoculants, and we see that as long as we increase seed yield potential, we have a response to inoculation. The response is less, it's like 5% than when we are in a field with no history of soil. But we always expect a response to inoculation. And the question is, why we think of applying fertilizing nitrogen in soybean? I just want to show you here what happens when we apply fertilizer nitrogen in soil. There is a negative relationship between the nitrates, that is what happens when how the nitrogen is in the soil, and the biological nitrogen fixation. And look at that, this relationship is an exponential decay. So here we have fertilizing nitrogen, here we have nitrogen fixation, and the decrease is non-linear, it's exponential. So the higher the fertilizer nitrogen we add, the less nitrogen fixation we have. So you must now have in mind that we are replacing, and this is something that we had to pay very high rates of money to pay than this. And this is an experiment, and that can show you clear this. This is an experiment that we made in a high yielding experiment, and this is a control without fertilization. This is the late nitrogen, is what we call, that's applying nitrogen, fertilizer nitrogen, like an R5 when the seed filling period is beginning. And this is another strategy of applying nitrogen as fertilizer just before planting or 50 parts during the V6, in the vegetative period. And we can see here is that if the nitrogen fixation can supply close to 50% of the total nitrogen requirements of the crop, when we apply nitrogen, we are reducing the application of the supplying of biological nitrogen fixation, that is here. We come to 38 or 32. The more nitrogen we have, the earlier we apply the nitrogen, the less nitrogen for biological nitrogen fixation we have for the soybean. But look at this, both of them, they can have the same amount of nitrogen. So there is here what we call here a trade-off nitrogen, that is nitrogen that can be taken by biological nitrogen fixation. Here you can keep here or here, and is replaced by fertilizer nitrogen. So this nitrogen that can be get by biological nitrogen fixation in this treatment are applied as fertilizer. I'm paying money for this, so I'm not getting a very good return. So biological nitrogen fixation, the inoculation process is that make me that I have a very safe nitrogen biological fixation process is necessary and is saving money for me. So the main conclusion here, when we are managing how I can manage the soybean nitrogen in soybean, the soybean crop, depends very much on the plant demand. The 80 kilograms of nitrogen per hectare is what the plant will require. And we have to deal with the biological nitrogen fixation process and the soil nitrogen. So both of them are in the same field, and we have to manage both. The less nitrogen, soil nitrogen I have, the more of the biological nitrogen fixation process I can get. So the sources for soybean are basically biological nitrogen fixation, the soil nitrogen, and fertilizer nitrogen is not necessary to apply. We have to think of this in very, very particular situations in which the plant physiological processes are constrained. For example, the pH, or for example, when we have a very dry season, but it's not the common thing. This is not the rule. Or the bacteria is not working, we have bad modulation. But this is the core of the nitrogen management in soil. I always take care that the high yield is always associated with high biological nitrogen fixation. So the better conditions that I make for the soybean crop, that is to say, the more growth that they can have if I correct some other nutrients constraints like phosphorus, sulfur, potassium, etc., whatever you have, independent of the soil, the better condition for biological nitrogen fixation we will have. So the optimization of the biological nitrogen fixation process is by inoculating, by having high effectivity strains, those strains that are the rhizobium has to be specific for the soybean crop, using high quality inoculants, and manage soil and crop in order to optimize the environmental for the rhizobium-soybean plant interaction. It's a must in soil without soybean storage. If I don't have soybean before, I don't have to forget it, because inoculation will introduce the bacteria in the soil. And in soils that have some soybean history, it may reduce the risk of a low nodulation as a result of the bad environmental condition, and we ensure to have the nodules in the upper 10 centimeter soils early in the season. So take into account that the recognition process is at the very beginning when the radicle goes out of the seed. So nitrogen fertilizer additions on surface do not give any advantage in terms of seed yield or protein content. Since fertilizer, as I showed you before, replace the biological nitrogen fixation, this trade-off that I mentioned before. And also, don't think about only the crop. Also, when we fertilize soybean with nitrogen, not only in the crop, but also in the fallow period, for example, if you apply nitrogen in the fallow, that is a common practice for maize in some countries, we increase the nitrate content in the soil. And also we reduce the contribution for biological nitrogen process. So if we manage nitrogen, it's okay for the maize, but it's not fine for the soybean crop. And this is crucial to increase the contribution of the biological nitrogen process in the system. So I invite you to go to this YouTube site. We have a very nice 2 minutes infography showing how the whole process of biological nitrogen fixation. You can configure the subtitles in your language, and I appreciate your invitation, and I hope you can have some questions for this. Thanks a lot.
Thank you, Dr. Fernando, for many information how you share with us and our farmers. Please tell us how are experience for your farmers with inoculation and how they using in their job.
How they made inoculation, you mean?
Yes, yes.
The inoculation process, there are several. The inoculant is sold. There are several companies that they sell inoculants. They can do it by themselves in the farms. Sometimes they can, but when you have small farms, you can manage with the inoculant. You can buy the inoculant. So before, a couple of days before planting the soybean, you can inoculate a good inoculation. We are always teaching the farmers how to inoculate, because you have to spread all the inoculant in the seeds. A bad inoculation you have better size.
Dr. Fernando, you told us a small or big farm. In Serbia, small farm is 500 hectare, and which is in Argentina?
This is a small farm. It's a medium farm. And when we talk about a big farm with like more than 1,000 hectares, 500 hectares is a farmer, medium farmer that are planting soybeans and other crop, and they can manage the inoculant by themselves. I think that it. The thing is just to buy a very good inoculant and have in mind that this is something that is very good for the crop. You have to maintain high quality inoculants to have high quality bacteria in the soil.
Thank you, Dr. Fernando.